Okay guys, this is just going to be a quick tutorial for 5.04 gas calculations. I've got a couple of practice problems up on the screen and I will work through those with you. The first thing I want you to know about problem number 6 is that since we are given a pressure and a temperature, we're not dealing with standard temperature and pressure, and so we need to use the formula PV equals nRT. All right, and then in this case, because it's asking me for how many grams of ethane gas is going to be produced, we are going to be dealing with the moles. Okay, let's go ahead and label those real quick. This is going to be P for pressure, V for volume, okay, N is the number of moles of the substance, R is the gas constant, and T is going to be your temperature in Kelvin. All right, and so if we plug this in, my preference is to rearrange the formula beforehand. It'll work either way. You can plug in the unknowns and the knowns and do the math, or rearrange the formula. I prefer to rearrange the formula, so I'm going to use PV equals nRT, and I want to get N by itself, and so I'm going to divide the right hand side by RT, which means I have to divide the left-hand side by RT as well, which will then give me N by itself, because I can cross out the RTs. And so my new formula is that the number of moles of a substance is going to be equal to the pressure times the volume divided by the constant times the temperature. All right, so now we plug in our unknowns. So reading through the question, it says how many grams of ethane gas are in a 12.7 liter sample. So I've got number of moles is equivalent to pressure is 1.6 atmospheres. I'm going to multiply that by 12.7 liters because that's the volume. I'm going to divide it by the gas constant, which is 0.0821, times it by the temperature. And just a quick side note, this temperature is given to us in Celsius, so it says it's 24, I'm going to write this down here, degrees Celsius. In order to get that to convert it to Kelvin, I need to add it to 273, and that's going to give me 297 Kelvin. Okay, so my temperature is 297 Kelvin. Okay, so 297 Kelvin. And so then we're just going to do some easy math to determine the number of moles. And so when I multiply this out, I'm going to multiply 1.6 times 12.7. I'm going to divide it by the quantity of 0.0821 times 297. And it comes up with the number of moles in this substance, the number of moles is going to be 0.833, right? And that is moles of ethane. So now I'm going to have to use my periodic table. If I'm in moles of ethane, I need to get to grams. So I'm going to go 0.833 moles of C2H6. And I need to convert that to grams. So I know moles. Oops. Go down here. So for every mole of ethane, and I am using carbon, we're going to just say 16 plus 6 hydrogen. This is going to be 30 grams of C2H6. Remember carbon, if you look at the periodic table, carbon is going to be right at 12. There's 2 carbons, which makes it 24, plus hydrogen, which is right at 1 times 6. So 24 plus 6 is 30. All right, and then I do that math, which is 0.833 times 30. Remember, my moles have crossed out, and so now I'm in the unit of grams of ethane, and that's where I want to be. And so once I solve, do the math problem, I now have 25.0 grams, and it is of ethane. And so there's my answer. All right, so if you want to pause your video right now and take a screenshot of that, you feel free. Otherwise, we're going to erase and we're going to go to the next one, which is how many liters of methane gas. Okay, so we're going to do one with volume. Okay, so in this problem, I have skipped down to number 9, and we're going to look at how many liters of oxygen gas can be produced if 28.7 grams of water decomposes at 294 Kelvin and 0.986 atmospheres. Please show all your work. And so what I'm going to start with, in this case, what I want to start with is the balanced chemical equation. So I'm going to go ahead and write that at the top of my page or wherever I'm working. So it's going to be 2 where am I? 2 water, right? And I'm going to decompose into 2 moles of hydrogen gas and 1 mole of oxygen gas. All right, and so now a good rule of thumb when we're starting these kinds of problems is to start with what you know. And what they gave us was 28.7 grams of water. Okay, so I know the first thing I'm going to have to do, since I'm trying to go to liters of oxygen, okay, the first thing I'm going to have to do is get this out of grams of water. And so I've made my equality here, and so on the bottom I've got grams of water, and I know that hydrogen weighs about 1, oxygen weighs about 16, so I'm looking at approximately 18 grams of water for every 1 mole of water. I can cross out the grams, and I'm left with mole of water. Okay, I'm going to come down to the next line. All right, and I know that I'm in moles, so I'm going to have to get rid of moles of water. And I can do that using the balanced chemical equation. So if I have 2 moles of water going in, I'm going to move my mouse here so you can see that. So I've got 2 moles of water coming in. I want to compare it to the oxygen coming out, which is just 1 mole. So for every 2 moles of water, I have 1 mole of oxygen gas being produced. I go through, I cross out my moles of water, and now I'm in, oops, I forgot to label, in moles of oxygen. Okay, moles, they want liters of oxygen though, so now that I have moles of oxygen, I'm going to have to use the formula to find the volume. All right, in this case, just like we did before, the volume is going to be equal to the number of moles times the gas constant times the temperature. It's going to be divided by the pressure, right? PV equals nRT. All we had to do here, I'll show you in the corner, PV equals nRT. If I want to get volume by itself, I just have to divide by the pressure. These two cross out, and now I've got my formula. Okay, so here we go. Let's plug in what we know. So we know we're looking for volume. We have the number of moles, which, let's do the math real quick, 28.7 times 1 divided by 2. So 28.7 divided by 2 equals, and this is going to be 27 here, times divided by 36. 28.7 times 1 divided by 36, and that equals 0.79. So right here, the number of moles, which is N, equals 0.797, and that's moles of oxygen. Okay, and then we're going to take that down here into our formula. So we've got the volume is equivalent to 0.797 moles times the gas constant times the temperature in Kelvin, and it's already in Kelvin for us, so we just have to plug it in. Okay, and I'm going to rewrite that because that looks very sloppy on the board. So here we go, volume equals the number of moles. Maybe if I write a little slower, it'll read it for me. There you go, 0.821 times the temperature. All right, that looks a little bit better. Okay, and then this is all going to be divided by the pressure, which is 0.986 atmospheres. Okay, and so if once I do these calculations, remember to do the numerator first, then divide by the denominator, and when I get the result, it's going to give me 19.5. The unit is going to be in liters. It's going to be oxygen gas. Okay. Oh gosh, you can't read that. So volume equals 19.5 liters of oxygen gas. So I'm just going to scratch this off because that's sloppy. All right. I hope this helps, guys. If you have any questions, please just give me a call. Thanks.